friends, welcome back. We're going to prove triangles are congruent today by overlapping triangles. We're going to deal with proofs that have these overlapping triangles. Now these proofs are going to be a little bit more complex than what we've been doing, but stick around, hang in there with me because I think you have all the definitions and theorems and proofs postulates, that kind of thing that you need in order to be able to prove these. So let's take a peek. Grab your notebook and we're going to write all this guy down. All right, first things first. We know FM is congruent to Fn. That's this guy right here. You'll notice I drew it out twice. If you have overlapping triangles, that sometimes helps. So FM, FM, Fn. There we go. Okay, so we also know that DM is congruent to Hn. All right, DM is congruent to Hn. We know that EF is congruent to GF. So EF is congruent to GF. All right, and we know that DE is congruent. So I'm going to do a little 4 dash here. That's kind of weird. 1, 2, 3, 4. Or not weird, just a lot. So I'm just putting in those dashes there. And 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so that is what we know. So we're going to write those down as our givens. All right, so for our next step, what we're going to do is say, remember, if you're not sure what to do with a proof, it doesn't hurt to see if you can do any obvious but not givens like reflexive property or vertical angles. See if segment addition postulate or angle addition postulate would work. Kind of start to play around with those things and you'll find that you are getting closer and closer to your proof. So we have MN is congruent to NM. So NM is congruent to MN, and that is because of the reflexive property. That is this guy right in here. Maybe I should use a different color instead of doing it 5 dash. That's kind of weird. All right, so I picked up another green marker. Get it together. Okay, so we know that this guy is going to be congruent to this one right here. So these triangles are starting to really look congruent because we get a lot of lines there saying that they are. However, what we have to do first is we have to say all of this stuff that we were given, we have to list that out as equals. Now, remember when we do that, that is the definition of congruency. Definition of congruency. Okay, so let's take a look at this. We have EF and GF here. What I've done is, if you see I have EF and GF here, what I've done for this, let me grab this other marker too. You'll find colors help in geometry. All right, so DM, HN, EF, GF. Okay, so all that I've done here is on that first one, I have added in an FN on both sides. If you do it on one side, you have to do it on the other. And on this one, I've added in an MN. And if you do it on one side, you're allowed to do it on the other. You just have to do it on the other. That's just your addition property of equality. Property of equality. So that's just your addition property. Okay, so now let's take a peek here. All right, well, at this point, I went from EFN to GF to FN. Oh, so you'll see now that I have made a change here from this guy. Let me find a highlighter here. All right, so we've got FN, you'll see, and then I went to FM like that. And I'm allowed to do that because back up here I said FM and FN are the same, right? Now down here, the change that I made was MN to NM. All right, so that is our substitution property. Substitution allows us to do that because we have said that those things are congruent before. All right, now, like I said earlier, okay, so on these guys, we have angle 6. Okay, EN is related to, or I'm sorry, EN and GM. Okay, good. So I had to find a good marker for this one. Okay, so for EN and GM, if we go back up here, let's take a quick look at this again. EF and FN. So EF and FN, that's these guys right here, EF and FN, right? That equals GF and FM. So in this case, we can say EN equals GM, sorry, Because of our segment addition postulate, because these two things are the exact same, and when added together, they're the exact same as this one. So all we have to say here is our segment addition, I think I just spelled that wrong, segment, yes, there's no E, addition postulate. Trying to talk and write at the same time is not working well. Okay, so the next thing that we've got to do here is, so now we know that these guys are congruent right here. All right, perfect. What we can say from there is, hey, we know they were equals. Now we know they're congruent. And this will be our definition of congruence. Definition of congruence. Now that I have said that, I can declare that these triangles are congruent, because if we go back and we look, we already know that this and this are congruent and these long ones are congruent. So all we have to say is, hey, DEN is congruent to GHM, or HGM, I'm sorry, for side, side, side. Okay, let's take a look at another one. All right, let's take a look at our next proof that we've got here. We are given that AC is congruent to AB. So AC here, this whole long thing is congruent to AB, which is right over here. Perfect. And you'll notice I split these triangles up because, again, if you have overlapping triangles, it's a good idea to split those up. I had a hard time visualizing that. So let me show you what I did here. I've got these guys, if I can pick this up, let's see. I've got these two triangles right here, which sort of match this guy right here, right? Pretend that this line's not there. And you see, if I rotate them around like this, I've got AEC like that, and I've got DEB. So I can see, oh, hey, B is going to overlap with C, D is going to overlap with A. And that means CE is going to overlap with BA. So I just cut those out so you could kind of visualize that as well. Okay, so D is the midpoint of AC, and E is the midpoint of AB. So D is the midpoint of AC. That must mean that AD and DC are congruent, and BE and EA are congruent, because that is the very definition of midpoint. So let's take a look. We've got our givens here. Now, as I mentioned, whenever you have like midpoint or bisector, you're going to want to use the definition. So the very definition of midpoint is that these guys are going to be congruent to each other. So AD is congruent to DC because of the definition of midpoint. Excellent. All right. Now, that also means if you're ever at a loss on what to do with a proof, that's a good idea to start. And also remember that we're probably at some point going to need to say, hey, these guys are congruent, not just equals, congruent. So it's a good idea just to throw that in there. We have AC is congruent to AB, because that is going to be our definition of congruence. And I meant to say, we're going to have to declare these guys congruent at some point. But in the meantime, let's do AC and AB as congruent instead, or as equals instead of congruent. Okay, so the other thing is, when you have some of these overlapping triangles, another good idea is see if you can't try segment addition postulate. So for this one, we know that AC is made up of AD plus DA. Same for AB over here. That's made up of AE and EB right here. And so if it helps, try doing segment addition postulate and see what happens. When you're doing proofs, segment addition postulate, I don't want to talk at the same time. When you're doing proofs, you can do it multiple different ways. You can take 20 steps to do a 3-step proof, as long as everything can be backed up with logic and reason and your definitions. It's correct. I mean, you went a really long way about it, but if you've got extra stuff in there, it's not a big deal. Just has to be backed up. Okay, so let's take a look now. Here's what we've got. So AC equals AE and EB. Now this is, it looks like what we've done from this 4th step to this 5th step is we took this AC and we put it in for AB over here. And we're allowed to do that because back up here we said AC and AB are the same thing. Therefore, I can swap these guys out. That's called our substitution. Substitution. And you want to specify, you can say AC equals AB. Okay, so let's take a look at this other one. I'm going to try and back this up so we can get everything into the screen at the same time. But AD plus DC equals AE and plus EB here. Okay, so looking at that guy, where did we get that from? Well, it looks like since we said AC equals all this garbage right here, and AC equals all this garbage right here, we might as well say that that equals each other, right? And that is the transitive property. All we did was cut out this middleman of AC and set them equal to each other. So that's a transitive property. Okay, so taking a look at our next one. Now, so oftentimes when you're doing these proofs and you do segment addition postulate, try substituting things in and then writing new sentences, because it's exactly what we're going to do here. Sneak peek, you can see the step 8. Okay, so for number 7 here, we have AD plus AD equals AE plus AE. This is because we know that we are allowed to, I guess, simplify this and say that, oh, I'm sorry, no, not simplify. We are substituting in, sorry, got to pay attention here. AD, DC. You'll see that we are, let's use a different color. So we took DC and we swapped it out with AD, and we took EB and swapped it out with AE, and we're allowed to do that because way back up here we said, hey, those two things are equal, so we can swap those out. That is called substitution. All right, substitution. Good. Now, for step 8, I am simplifying this, and some geometry teachers will say that that's actually considered substitution, but I think simplify works. Let your teacher, your teacher may have something else to say. Simplify, because we have AD, so now we have 2 ADs and we have 2 AEs. Okay, for the next part, I want to get rid of those 2's. So I have AD equals AE. All I did was divide both sides by 2, and that's just division. Remember, if I do it to one side, I have to do it to the other. That's division, technically property of equality. All right, for 10, remember what I said. If you're going to use equals, it's probably not a bad idea to do congruence somewhere. So all we did from AD to AE is say that these guys are congruent, and that is the definition of congruence. You're going to get real familiar with that one. That's a fun one. Okay, so now what we can say is, let's see. If I say that angle A right up here is congruent to this angle A, remember, so in addition to segment addition postulate and any definitions, you can do your obvious but not givens. And this is a good obvious but not given. It is the reflexive property. Angle A is congruent to angle A because of course it is. It's the exact same angle. But still, we don't assume anything in geometry. So we say reflexive property, allows us to say that about AE. Okay, so then we've got AE and, oh, whoops, I forgot to mark this guy. AD and AE. These are congruent. Oh, so this is really helpful because if you look at that, we now have angle side, that we can declare these triangles are congruent. Again, we're trying to prove that DB is congruent to EC, right? So if we can declare these triangles are congruent, then we can say, hey, corresponding parts of congruent triangles are also congruent. So if we look at that, that's exactly what we've done here. We have said, okay, these two triangles are now congruent because of side, angle, side. And because those are congruent, that means their corresponding parts of congruent triangles are also congruent. Excellent work, friends. Thank you for hanging in there. These are some tough proofs, and we'll see you next time.